Hello. So this session is about the performance testing for API endpoints. So I will take the public free API source of this uh, request response .in API asset, and let me show the uh, Jmeter JMX file that I created for this. So the test plan name I have kept it as request response test plan. URL, the user defined variables I have declared here, both URL and the protocol. In the uh, uh, in the thread groups, what we add under the test plan section here, I have utilized two thread groups. One for the arrival thread groups to play with the throughput of the endpoints, and other one is the ultimate thread group. Both use cases let me show. Number one, for the arrival thread group, I have kept the uh, arrival rate as 5 transactions per minute. That's the expectation I have kept. And the ramp up time I have kept it as 1 minute, meaning within a single the 5 transactions per second per minute has to be achieved. Then after that ramp up time, which happens in a step count of 3, the whole duration of 1 more minute is kept. So totally duration of 2 minutes, and inside that 2 minutes, the arrival rate has to be 5 per minute. That is the scenario I have taken. Since this is a open source free API, I have not what to say made much of a stress for that API resource by creating a 50 100 per minute. So I've kept a very low level of load on that API asset. So for sake of explanation, we will understand with help of this low load. So 5 different endpoints under that request response.in API asset we have taken for our understanding. The list of users get, and then single user get, creating a user, update, patch, and delete. So totally 6 requests we have taken. Now, if you see, by expanding one single request, uh, so how do you first of all add a particular HTTP request under a thread group? First, that we will see. So right click that uh, thread group and say add a sampler. You can add this HTTP request. Okay, once we add that, we are naming that as get list of users. The protocol and the uh, URL part we are taking from the test plan user defined variable level. It's a get request, that's why we are selecting that get request here. After that, the endpoint URL we are passing here. What are the items that we need to pass as supporting items to the HTTP request? So you need a header manager. So right click that HTTP request and say add conflict element and HTTP header manager. You can add that, and to capture the uh, any result coming out of that endpoint post process, you can add a JSON extractor and a bean shell post processor, both of which I have added here. For sake of assertions, we are adding uh, two assertions. One is a response and other is a duration. So under assertions, response and duration we can add. There are a number of other items also which we can add. For demonstration sake, let's take this. Now um, let's run this and see. For time being, let's disable this other thread group and focus on the uh, arrival thread group only for now. So let's save, clear the logs and run it. So as soon as we run, the results tree gets generated. Let's stop it and understand from this uh, one set of all 6 endpoints run results. Let's begin with this get list of users, and uh, we are seeing this through the view results tree only. How we are getting this is when we right click the thread group, we are adding the listeners. These listeners are helpful in viewing the results of our performance test. So for our demonstration, we have taken a view results tree, aggregate report, and assertion results. Why assertion results are required? Because we have added these assertions here. To view them, we are utilizing it. Now, under the view results tree, back to this area, the first request is the get list of users. So the sample result tells us that the response code seems to be 200. Okay, it's fine. What are the size of the request response, all those things. Overview or a gist, it gives us all the details here. If we go into the request, it has the two subsections called request body that and also the request headers. Under the request body, it tells details about what is the get endpoint uh, and any other data. Now, under the request headers, whatever headers we are passing to the endpoint through this header manager, okay, these things are getting visible to us here under the request headers. Similarly, we have the response header. It's a response body. What response the endpoint produces and what are the response headers. So these things we are able to view. Now, under the uh, under the aggregate report, if we see, it tells us how many samples are totally run per endpoint and what are the different time related metrics like average, how much seconds it took. So all these things are at the millisecond level. Median value, 90 percentage of the samples got completed within 755 millisecond, 95 percentage got completed at less than 755. Similarly for 99 percentage, min max value, how much percentage of samples totally failed. Say 100 samples ran, out of that 5% failed, which means 5 samples have got failure. We need to investigate like why it got failed, what is the response error code. All those things we'll be able to validate with help of the report, which we say see at a later level in this demonstration. Now, throughput is nothing but it's able to achieve 1.3 transactions per second. That's the throughput we see here. And received KB, sent KB, these are nothing but when the request sample is sent, how much of the KB is sent and received, that size is displayed here. So for all 6 endpoints, these statistics are available, and the total it tells the total value for all these fields. It's able to give us an average value here. Okay, that's about the aggregate report. Assertion result, it generally gives us the name of the HTTP request, meaning the name of the endpoint what we are passing, that it is able to tell us here. If at all we have any errors, it will be able to show us here. Now let's take one example for that. Let me clear the logging, go to the uh, 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 go to the response assertion, and intentionally I am making the expected result of this get call to be 201. Let me save it and let me now run it. Let's stop. If you observe, it's saying it received 200, but in comparison the expectation is 201. So that's why the test failed and the response assertion is seen here. Now, under the response assertion, there are many things that we can validate. Example, not just the response code, a text response what we receive, and the response code along with the message. Okay, 201 created a response message we can validate. Response headers, request headers, all such things we can validate. And whether the validation has to happen only for the main sample or subsamples also. So what are subsamples? Any request redirection that happens from a parent API call, and that also can be checked. That subsamples can also be checked. So these things we can validate under the response assertion. Now, under the under the duration assertion, we can define like within 1,000 milliseconds, meaning less than 1 second, my response has to be seen. If the response is taking more than that time, then it's going to flag an error for that. So we are declaring that assertion. Now this is for the get list of users. Similarly, for a get single user, other things also we have done like that. Only difference being for the update patch request, we will have to pass the request to body under the body data section, and the respective HTTP request like post put we need to do. So that's about the individual request. Now, if you observe under the get request only, we have added two other items called the JSON extractor ID and the bean shell post processor. These two things are post processing extraction tools only. In our response body, we are checking the value for the ID field under data array. So that we are checking here. If we observe under the get list of users uh, response body, under the data section, we are capturing the ID here. That's what we are doing. Let's go back. That ID, whatever we have captured, we are storing it inside the a variable called ID. And are we interested in doing a random match or any specific match? We are interested in doing a specific match. That's why we are telling capture the first occurrence of this particular JSON path. And if it doesn't return any value, then we are saying give us a default value of 7. So after capturing this data inside the created variable called ID, under the bean shell post processor, we are storing that ID inside one global property called ID. So once we store this inside the ID, what we can do is in the get single user, we can do the request chaining. So give that global parameter called ID here from this post processor. The small ID is nothing but what we captured through the JSON extractor here. This is the created variable. We are storing that inside the global parameter set property called ID, and pass that global parameter here in the get call endpoint URL. And similarly here we are passing the respective HTTP header manager, all those things. So the response assertion duration assertion, these are same thing as the first request. If we observe the get single request here, you will see that the request has gone for the value of 7. Okay, as because the first value what we have extracted here is nothing but 7. So you may have a doubt that the default value I have given as 7, that's why it's taking 7. Let's change that to 8 and check. So get list of users, the first value here we are seeing 7, and the single user request, it's going for 7 only and not the default value of 8. So we are doing a request chaining here, and also the validations of assertions whatever we need here that we can create. Similarly for the create, update, patch and delete request. Now this is about the arrival thread group. Now let's disable this for a minute, and we will see this ultimate thread group. Why we need this ultimate thread group? We have the option here to define the load scenario. Like initially I need this thread group to have two thread counts. Two users are actively logging into that session and doing some activity, and I don't want any initial delay, and there is no a startup time like ramping up all those things. So two users, they have to be hold it for 60 seconds. Then after that extra two users I'm adding now. You see that initially two and extra two we are seeing now, and the initial delay is 10 seconds. That's why you see the 10 seconds delay time. And again there is no ramp up time, it's one single shot. It's rising up, and the whole duration is 40 seconds. So from here from 10 seconds, till 40 seconds, meaning 10 plus 40 is 50. 50 seconds, this extra two users will be available. Then extra two users again we are adding up, and that is seen here. And initial delay is 20 seconds. That's why right from start till 20 second, the fifth and sixth user are not available. They are available from the 21st second only. That's visible here, and we are holding that for how long? 10 seconds here, as seen here. And there is no startup time, ramp time, so it's vertically climbing up. So that's the graph for you. And once we achieve that particular peak, nowhere we have defined a shutdown time. So the shutdown is instantaneously happening. That's why you see on stroke of 30 seconds, 20 plus 10, you see that the shutdown is happening with help of 0 seconds. So two users are getting dropped here. And similarly, upon completion of 50 seconds, meaning 10 plus 40, 50, you see a decline of two users because the shutdown time is here 0. And the first two users which were added, they were held for 60 seconds. So as soon as 1 minute is reached here, there a decline is seen here because the shutdown time here is 0. So we can play with this graph as per the setting what we do here. So incrementally, uh, to the to play with the users on a particular API endpoint or asset totally, we can utilize this ultimate thread group. Now again, the same set of endpoints only we are seeing here, and there's nothing separate to explain. So tool wise, Jmeter, this is the manual way of explaining test cases. Now let's uh, see how we can place this JMX file within the GitHub and utilize both GitHub Actions and also the uh, Jenkins to achieve a CI/CD. Now, uh, the Jmeter JMX file, we need to first place it in the GitHub repository. Let's first uh, save this test plan under some area. Now, I have already done it under a particular folder. So that's saved as request response test plan. Okay, let me go to that area, and here we can do a git bash. In our GitHub uh, URL, we should already have our repository created. If not, create one new and keep it ready. I have this Jmeter Newman uh, repository available. Let me go inside that, and from here I should first say git add dot, so that all the files here will be placed in a from the local repository to next level. As soon as I add the files, then I should say git commit hyphen m, a commit message. Let me give, I should give some meaningful message here, like placing JMX file in repo, something like that we can say. After committing the file, um, if it's the first time that we are adding the remote repository URL to our git bash here, then we should say git add followed by the URL of that GitHub repository. We can take that from here, HTTPS. Once the uh, uh, repository is linked here, then we can do a git push, so that the files from our local system here, it will be placed in the remote repository. If at all we already have some existing files in the git repo, then we can do a pull, update the file with whatever changes we need, then we can do a push. So that's about placing the uh, files in the GitHub repository. So once we have done that, To work with GitHub Actions, we need to have this GitHub workflows folder. Inside that, we should write our YAML file. That YAML file, it should contain the instructions to uh, run this uh, JMX file. So what we have done here, we have given a name to this uh, GitHub workflow action. On what trigger we need to run this JMX file. We are saying on push activity from the on push activity to the branch called main, run this pipeline. We are saying a job we need to declare. What's the job? Uh, it's called Jmeter test. That's the name, and it runs on some mission needs to be allocated. We are calling the Ubuntu machine. Our latest tag is the recent version of the Ubuntu machine. Steps we need to declare the items one below the other. First, a checkout activity is necessary to utilize the files from our repository. Then setting up the JMeter with help of the run command, uh, followed by install the plugin manager, because under the JMeter, if you observe, under the tools, under the options, you have this plugin manager through which only um, the custom plugins like arrival thread group needs to be added. So similarly, we are asking the uh, plugin manager to be installed here along with the custom thread groups. That activity we are doing. Run the Jmeter test with help of this particular command. So we are passing the test plan name, the JMX file, and we are saying store the result logs in the JTL format file. And next step will be for generating the HTML reports, followed by uh, archiving or uploading that HTML report for report checking purpose. So this is about the uh, YAML file what we have written. Now inside the actions tab, whenever we see a push activity to the uh, to our repository, then this particular YAML file will run, and we should see the test execution as separate run under this workflow. Here in our case, let's take this recent run, and we see that uh, all these steps have happened, and the report got generated. First, a checkout activity, followed by installation of the Jmeter, then install the plugin, a manager and custom thread group, run the Jmeter test plan. Now, if you see all the uh, runs within that Jmeter JMX file that has happened, under tidying up of action, winding up of the run has happened, followed by the generation of the HTML report that has also succeeded. Upload it as an artifact, so that you should see that under the link here. So that's about the run. If you see the summary report, you should have that artifact available here. In my case, I had downloaded that already, I believe. Let's check that. Um, if you see, it's from the source file results GTL, and totally 99.93 uh, percentage has passed, and 0.07 is the failure percentage. For each of the requests, these many samples have got run, and error percentage for each of the sample is visible. the millisecond level of response time statistics for different metrics like average, min, max, median, percentile value, and the throughput level, received and sent bytes, the KB data, and error. What are the things we are facing? Since we have added an assertion for the response time to be less than 1000 milliseconds, there are a few samples that did not meet out that criteria. That's the reason we are seeing that. So totally two samples have only got errors. And that's why a 50 percentage for this sample and 50 percentage for this sample. Totally 100 percentage, meaning two samples have got failure. One for this and one for this. Okay, so here it took a 793 millisecond. Here it is 1.093 millisecond. Both have got failed. Now the top 5 errors by sample, that is also visible here. So total two samples only, and where they have come from. One is from the delete user, other is from the get list of users. So these two things are visible here. Okay, out of the total 466 samples, one error has happened. Out of 476, one error has happened. What is that? This is the error, and how much of samples have taken a hit because of this error? One. So that's how we read this. And inside, if we see under the charts, you will see different charts to depict the same data. uh, so if we go through each of these things, we will get an idea, like how pictorially the same data is mapped here, whatever statistics we saw under the dashboard section. So that's about the HTML report part. Now the same detail, continuous integration, we can do it via the Jenkins also. How we are doing it? Under the settings section of this repository, we will have this webhook. This webhook we need to configure for the Jenkins. Let's go to our Jenkins dashboard, and if you observe, our local host 8083 is the place where we are hosting this Jenkins service now. For us to configure that Jenkins here, we need a public IP, not the local host. So ngrok is the service we are utilizing for generating that public IP. Uh, and let's take this particular URL, public IP URL, and place it inside this webhook area. Once we have done that, here we need to suffix it with this GitHub webhook keyword, and content type should be application JSON, and we are interested towards the push event only. And if at all we have a necessity to select any other events, that we can select here also, but for time being, let's use this push event and update the webhook. So in this way, we have configured this GitHub action to forward the uh, repository files to the Jenkins. Under the Jenkins, we have a project called Jenkins. The Jmeter GitHub Jenkins integration. This freestyle project we have, uh, and inside this project, we have done the configuration uh, to support this Jmeter run. Let me show that. It's taking more time. Let's go again to that project and open this configuration in a separate tab. Meanwhile, we will check what are the global tools and plugins that we have configured under the Jenkins section of the dashboard. Under the tools section, okay, the project level configuration has got opened. Let's see that. So the source code management, we have defined the Git repository here, along with the credentials, username and the password. Password is nothing but the personal access token what we generate at the GitHub level, a one-time activity. We create and configure that here. And branches to look for, we are building using the main branch only for time being. And triggers, we are enabling this polling GitHub hook trigger so that the webhook will be able to reach this. And the build step, we are adding one execute Windows batch command a step, and we are declaring the uh, newman not newman, we are declaring the command necessary to run the test plan, that is the JMX file here. So that we have declared here. And the post build action, we are trying to archive the artifact inside this particular file location, and publish a HTML report is also done. We are giving a path for that as well. And the name of the index page will be index.html. Report title, we are giving it, and we are saving that here. And inside the global configuration area, we have our Java JDK installation available, and Git is this default, followed by Maven installation and Node.js installation, both of which I don't think is necessary for this. Just the Java path should be okay. Uh, Now coming back to our uh, uh, freestyle project. Now, if you observe, the most recent run was done for yesterday, uh, and we see the console output here uh, to capture the details of our run. So these are the Jmeter runs we see here, and it's tidying up and archiving the HTML report at some location what we have defined, and the status here is success. Now what we will do, we will go to our GitHub repository, go to the code, do some little change so that the uh, GitHub webhook triggers the Jenkins. Let's do that. Let's edit some file here. Let's change the name of the test plan. Little change, and we'll update it. Okay. So it's saying that for today, 10:59, we are seeing a build that is currently happening now. In this way, a trigger from our GitHub towards the Jenkins happens. and that's what I was about to capture in this recording.